Hey, what's up, guys? Chung here again. And today I want to talk about this LeetCode problem 1466. Reorder routes to make all paths lead to CD0. Yeah, this is a graph problem. I think if I find out this is I figure out this is interesting problems. That's why I wanna try to explain this to you guys. Okay, so let's take a look. There are like n cities here, and from number 0 to n minus 1. And so the way they're defining this graph is it's a directed graph. Basically, there's only one edge between two nodes. And so yeah, I try to put some fancy words here. You know, most of the time, for this kind of graph problems, all those kind of descriptions, it's just trying to confuse you. Basically, it just tells you, it try to give you like a fancy explanation, but in the end, it's just a graph here. And it's basically you need to filter out all those kind of unnecessary informations and dive right into the root of this problem. So here it asks you okay, last year the Ministry of Transport decided to orient the roads in one direction because they're too narrow. Okay, that's why they only have one road between two cities. And then like okay, so the connection is from A to B. And this year there will be a big event in capital zero, and many people want to travel to the city. And your task consists of reorienting some roads such that each city can visit city zero. Return the minimum numbers of address changed. Okay, so basically you have a directed graph here. And for example, this one, right? 0 to 1, 1 to 3, and the address is stored. It's represented in the form of a list of a 2D array here, right? And then it asks you, in order for all the cities to be able to get to 0, how many edges you need to reverse, okay? Mm, yeah. So I mean, at the first glance, you will be like, So for this one, okay, for 0, 1, I need to reverse it. But how about 1, 3? Okay, I also need to check if 1, 3 is like, also this also needs to be reversed. Okay, and then from 3 to 2, I cannot go from 3 to 2, right? That's a problem. Okay, should I just store all the inbound edges for 3 and then try to see, okay, how many edges we have left for 3, and then we can reverse it. Okay, and same thing here, right? I mean, if you go that route, most likely you will be end up in some very complicated codes. So for this problem, next time when you guys see this kind of problem, have a very tricky things here. So what's uh okay, so the the purpose of this problem, right, is to first we need to traverse to all the nodes, right? And then we can decide, but on our way traversing to each node, have we seen any of this direction nodes? Like basically the on the forward direction. If we ever seen any forward directions, then we know, okay, that's the edge we need to reverse. I think that's the only part we uh, need to realize here. Basically, first we'll be treating this graph from a directed graph to a undirected. Okay, and because only after like converting this graph to an undirected graph, we can we can make sure so that we can make sure we can traverse to all the all the nodes or all the cities. And while on our way to each cities, we have a node and the neighbor, right? And we just check if this edge is inside of our connections, right? Basically, if it's in our connections, and then we know, okay, that's the edge we need to reverse. Otherwise, we just keep going. Yeah, basically that's pretty much it is. And and in order to check, like I said, for example, let's say we have from zero to 1, right? And then we know, okay, 0, 1, we need to know if 0, 1, this edge is inside the connections, right? So we just need to check it's in the connection. But be careful here. So the data size of the connection, so let's see the size of the connection. Basically, n is 10 to the power of 4, right? And if we do a linear check, basically, if for each of them, if we do a linear check, that's going to be n squared time complexity. So with the data size n 10 to the power of 4, that will definitely TLE. So very, very simple, right? So a very easy way to reduce that from ON to O1 is we convert this list into a set. Okay, after converting to the set, then next time we do a search, it will be just O1. Okay. Okay, so cool. So I think that's pretty much it is. So basically we're gonna convert to undirected graph here. That's all we need to do here. Right? So for for start and end, right? Or from to whatever you prefer in connections. Okay. Graph, right? Start dot append graph end dot append, right? That's how we define an undirected graph. Okay, and then we need a connection set here, right? I mean, we can put it here because the way there are like many ways to convert to a set, but I think we can either do the same for loop here, but I'm just going to just make it out, do it here. Basically, I'm just doing yeah, actually, you know what? Actually, I should have just do it here, since we are looping through the connections anyway, right? So I'm gonna just do a connections set dot add, right? And as end, okay? That's how we convert this connection list to a connection set. Since we're going to build the graph anyway, might as well just utilize the same for loop here, okay? And then after that, we need the answer here, right? And then all it left is we're gonna call it DFS. Gonna DFS 0, okay? And then in the end, we simply return the answer here. Now all it's left is just uh, sure. So of course, so the graph we always need like a visited, right? A visited set. Help us remember which node had been visited before at the beginning, which setting 0 to it, and then for neighbors, right? For neighbor in graph dot node, okay? If neighbor not in visited, okay? And then we're gonna basically do another DFS, right? Okay, so first we're gonna add the visited, add a neighbor to the visited set, okay? And then do another DFS, neighbor. Okay, so right, so that's the basic DFS template, right? And the only difference here is that since we're going to check the answer here, how many edges we need to to reverse. That's so all we need to check here is we have the direction here, right? So basically any direction from node to neighbor, because we're starting from 0, right? We're going like forward, right? Basically, as long as if the node dot neighbor, if the if this side if this going forward edge is in the set, the connection dot set, right? And then we simply do an answer plus 1. That's all we need to check, okay, right? Since we already converted this one to a set. As long as there's a forward edges, then we know, okay, that's the edge we need to reverse. Other than that, we just let it keep the DFS traversing. Yeah, I think this should just work. Oh, sorry. Since we're updating the global variable, we're gonna need to do a non-local answer here. Okay, then do the run code. Hmm? 5? Oh, actually, right. Uh, so I think first we need to check if the neighbor has not been visited, and then we do this check. Yeah, so we have to check if the node is visited or not. If the neighbor has been visited before, we don't even need to, we don't do this check. Okay, we only check it when it's a new. We only do this check when this neighbor is a new neighbor, a node that had not been visited before. And then yeah, submit. Cool. Yeah, I think why this one is kind of slow. Hmm. This time it's much better. Okay. Anyway, so a quick recap. It's a very interesting graph problem. The only thing you need to to notice that the essence of this problem, right? So the root of this problem is it just asks you to traverse the entire graph. And while traversing the graph, you just need to remember to count how many forward direction edges we have met, we had encountered, and that's the basically that's all that will be the final answer. Yeah, I mean sometimes you have to be able to convert this kind of fancy description or fancy problem into a very like a naive or basic approach. Basically, the basic approach is next time, maybe even for me, next time when I see this kind of problem, our first hunch or hint should be always, okay, let's try to since we're going to I mean we have to traverse to all the edges anyway, right? So then why not just start with the undirected graph, right? And so the next time we should always like try to build the undirected graph so that we can traverse to all the nodes, and then we just try to implement DFS. Maybe I think along while we're implementing the DFS, then it shouldn't be that hard for us to realize that okay, so while we're traversing the graph, all we need to check is have we seen this if this if this like this forward direction edges is in the connection, right? That's all we need. That's all we need to add. Hmm. And other than that, just a very standard DFS template with a undirected graph. Cool. I think that's it for this problem. Thank you so much for watching the video, guys, and I hope you guys learned something. At least I I did. Yeah. All right. Stay tuned and see you guys soon. Bye bye.